Okay, so number 62 on page 22 in chapter 1 says, the dimensions of aluminum foil in a box for sale in supermarkets are 66 and 2/3 yards by 12 inches. The mass of the foil is 0.83 kilograms. If its density is 2.70 grams per centimeters cubed, then what is the thickness of the foil in inches? So first, what we know is that the foil is 0.83 grams, and the density of that is 2.70 grams per centimeter cube. So after that, it helps me, I don't know if it might help you, to draw a little diagram. So you know that the width is 12 inches and it is 66 and 2/3 yards long. So you may think that aluminum foil is 2D because it looks just like a flat shape, but really it's 3D because it has a really, really small width, or a really small height. So what you do first is a lot of dimensional analysis. You're given it in kilograms, and you need to get that into grams because that's the way it is in density. And if you find dimensional analysis hard, this is the way I like to do it. So you put the thing you know, 0.83 kilograms, and we want that in grams. So I make this little, like, 2 lines with a fraction. So we know that to get rid of kilograms, we need that to be in the denominator, because once we solve, the 2 units cancel out, and then we're left with grams, which is what we want. So 0.83 times 1,000 grams per 1 kilogram, because that's the conversion factor, gives you 830 grams. And then from there, we did another dimensional analysis, because the density states that it's 2.70 grams per centimeters cubed. So 2.7 here is on the bottom now. So then again, the units cancel, and you're left with centimeters cubed. So the answer to that is 307.407 centimeters cubed. Now we have to convert the 66 and 2/3 yards to inches. So I did my dimensional analysis when yards cancel, because there's 36 inches in 1 yard, and you get 2,400 inches. To convert your original answer of 307.407 centimeters cubed, you have to look up, because you don't know how many centimeters cubed there are in inches cubed. So Google told me that it's 0.06102 inches cubed for every centimeters cubed. So when you cancel out the centimeters cubed, you're left with inches cubed, approximately. So right now I'm just doing shorthand, which means that I'm not doing significant figures for each one, because you want to store the answers in your calculator so you get the most exact answer at the end. And the volume formula is base times width times height, which gives you volume in units cubed. So we know that from here, that is our area of the total aluminum foil, because it gave you grams and density, and we were able to solve for the volume. So you know that you're going to have to multiply the base times the height times the width. So the width here is 12 inches, and the length is 2,400 inches, as we calculated up here. So h is our variable. The small height that's in aluminum foil is our variable. And when we solve that and divide the 18.759 by 2,400 times 12, we get the height to be 6.5 times 10 to the negative 4th inches thick. And this answer makes sense because aluminum foil is so thin. So don't be afraid if it's a really small number.